This is the third part of polar equation of conics. Okay, so this is part 3 of polar equation of conics. So here is another example of polar equations for conics. But before I go to this example, I want to mention one more thing which I forgot. Okay, what if my eccentricity is 0? Then it is a circle. Okay, one more time. What if my eccentricity is 0? Then it is a circle. Okay, so again, if E is 0, you have a circle. If E is between 0 and 1, you have ellipse. If you have E is equal to 1, parabola. E is greater than 1, hyperbola. Okay, so that's what I forgot about. It's the circle from the first part of the video. Okay, so if E is 0, you have a circle. Okay, so let's go back to this example. Okay, here you have R equal 4 all over 1 plus cos theta. Now if you look very carefully, this is already a 1. So since this is already a 1, there's no need to divide. Okay, one more time. If this is a 1, there's no need to divide. Okay, so just leave it the way it is. Okay, now the next step is to find E. E is right here. Okay, please do not say 0. E is always in front of the sine or cos. It's always in front of sine or cos. Please do not say 0 if you don't see a number. It is always a 1. Okay, so here E is 1. So since it is 1, you have a parabola. Okay, ED is always on top. Okay, ED is always on top, so make it equal to 4. Go find D, so put E in for 1. 1D is just D. D is equal to 4. What is D? It is the distance from the directrix to the pole. Again, D is the distance from the directrix to the pole axis. Okay. Now, next we need to find these points. So again, always use 90, 0, 90, 180, 270. Okay. Now, before we do this, to find the points, if you look very carefully, it says plus cos. It says plus cos. Okay. So let me go back to the other page. Okay. To the page where it says plus cos. Where does it face? Okay. So here it is. Since it is plus cos, it is faced to the left. Okay, so if you remember this page right here, plus sine, face down, minus sine, face up. Okay, plus cos to the left, minus cos, face right. Okay, so since in our example, it is plus cos, we know that it is face left. So therefore my directrix has to be on the right side. And since my directrix is on the right side, then it has to be plus. Okay. So let's get these 4 points. Again, always use 0, 90, 180, 270. So go back to the original equation, put 0 in for cos. Now we know that cos 0 is 1. 1 plus 1 is 2. 4 divided by 2 gives me 2. So that's our first point right here, 0, 2. Put 90 in. Cos 90 is 0. 1 plus 0 is 1. 4 divided by 1 is 4, which is here, my second point. Now with parabola, you only need 3 points. And the reason is because there is no fourth point. So therefore, 180, we don't need 180. Okay, there is no point on this side. Literally, there is no point on the axis. Okay. So that's why we don't need 180. We still use 0, 90, 180, 270. But if you remember, parabola, you only have 3 points. You don't have a point on this axis right here. You don't have a point, so there's no need for 180. Okay, so move on to 270. So put 270 in, cos 270. Okay, so cos 270, which is 0, 1 plus 0 is 1. 4 divided by 1 is 4, which is here. Okay, So be very, very careful. Again, parabola, if you remember parabola, there is no point on this side. Literally, there's no point on this axis. So that's why we don't need 180. Okay, but still, you still use 0, 90, 180, and 270. But because of parabola, there is no point on this axis. So that's why we don't need 180. Okay, we're not going to use 180. Okay, so there's our 3 points, 0, 2, 0, 4, and also 0, 4 here. Okay, so that is a rough sketch of the parabola. Okay, rough sketch of this here. Okay, now with parabola, there's only one focus, which is always right there. Okay, now we need to find next we need to find our vertex. So just by looking at our graph, should be easy that our vertex is right here. This is our vertex. Okay, 2, 0. Our vertex is here, 2, 0. Okay, next we need to find P for parabola. P is always the distance from the vertex to the directrix. So since from here to here, okay, the distance, okay, so the distance of P is from vertex to the directrix. Okay, now since the distance from the directrix to the pole is 4, so half of this will be 2. Okay, so one more time. The distance from the directrix to the pole is 4, right here, 4. But P is half of this. So just divide by 2. So there it is, 2. You have 2 units. 1, 2. Okay, so one more time. The distance from the directrix to the pole is 4. But P is halfway from the vertex to the directrix. So just divide by 2. So technically from vertex to the directrix is 2. Okay, so that's what P is. P is 2. However, why is this negative? Because it's facing left. If this was facing right, then it is positive. Okay, so one more time. Because it's open left, your P is negative. Because it's open left, P is negative. What if it's open right? So if it's right, then it will be positive. Okay, if it's right, then it will be positive. Okay, so open left, P will be negative. Open right, then P will be positive. Okay, so now we know what vertex is, and we need to know what P is. Okay, now also from this point right here, from this point to this axis, it is always 2P. Okay, just by looking at it carefully, if you look at this very carefully, from the directrix to the pole, it is 2P. So therefore, this distance here, where my pen is moving from here to here, it is the same distance from the focus to this point. It is the same distance. Okay, so from the directrix to the pole axis, it is the same distance from here to here. Okay, and this is where my focus is always will be. Okay, my focus will be here. Okay, all right, so now we know what our vertex is and we know what our P is. Now we need to convert this into rectangular form. But before we do that, again, this equation is this graph, okay, which is a parabola. How do I know that? Because my E is 1. Okay, always use 0, 90, 180, 270. Now, but also be careful. Parabola, there is no point on this axis, so that's why we're skipping 180. Okay. All right. So to convert polar equation into rectangular equations, you need to use these two forms. If it's horizontal, you use this form. If it's vertical, you use this form. Okay. But if you look very carefully, our graph is horizontal. Our graph is horizontal. Okay, so therefore we use this form. One more time. Our graph is horizontal. So we use this form. Okay, so we know what our vertex is, which is 2, 0. We know our P is -2. So just plug them in. K is 0, H is 2. Okay, K is 0, H is 2 right here. And my P is -2. There's my P. Okay, P is right here, -2. So again, K here, H here, P -2. And then just clean this up. 1 subtracts y subtracts 0 is just y, so y squared. 4 times -2 is -8. And then just x minus 2. And just leave it as is. Okay, so this is polar equation into rectangular equation. Okay, now let's get a better graph of this so that you can see, so that I hope it will make it easier to see this. Okay, so and easier to understand. So what I have here is just approximations. Here is a better graph. Okay, so same thing. Here's my directric from here to here. The distance from the directric to the pole is 4 units. Okay, here's my vertex and here's my P. From vertex to the directric is halfway. Okay, so just 2. From here to here is the same distance as from the focus to this point. Okay, so the distance from here to here is the same distance as from the focus to this point. Okay, and this is rectangular form, this is polar form. Okay, same graph, just different way of writing. Rectangular, polar. Okay, so I hope this helps out for part 3.